Hi, welcome back to geometry. This is section 4.4, congruence in right triangles. Our objective in this lesson is to prove right triangles are congruent. So this lesson only pertains to right triangles using Hypotenuse Leg Theorem, or HL. So we already have three postulates and one theorem. We have side, 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 angle, side, angle, side, and angle, side, angle. And now HL. The thing with the other four is that they could pertain to any two triangles. Hypotenuse leg only pertains to right triangles, because right triangles are the only kinds of triangles that have a hypotenuse. In a right triangle, the side opposite the right angle, so from your right angle, when you go across, is the hypotenuse. It's the longest side of the triangle. The other two sides, the ones that form the letter L, they are the legs. They make the letter L, the legs. So the side across from the right angle is the hypotenuse, and the other two sides are the legs. So today we're going to talk about congruence in only right triangles, because only right triangles have a hypotenuse. So the essential understanding of this section is that you can prove two triangles are congruent without having to show that all of the corresponding parts are congruent. In this lesson, we will prove right triangles are congruent by using one pair of right angles, so you have to know that it's a right triangle, one pair of congruent hypotenuse, so you have to know the hypotenuse is congruent, that's the side across from the right angle, and a pair of congruent legs. So you just need to know one pair of legs is congruent. So you might remember I told you we couldn't have angle, side, side. Do you remember that? Well, only right triangles can, and we don't call it that, because in geometry that would be a square. Right triangles, the angle, the side, well, this side is a leg, and the hypotenuse. So we don't call these side, side. We call them leg and hypotenuse, which is why this is called the hypotenuse leg. So in your template, write the hypotenuse leg theorem, HL. If the hypotenuse and a leg of one right triangle, again, very important that the first thing you notice is, are these right triangles? That means that you would know that there's a right angle. If the hypotenuse and the legs, so a congruent pair of hypotenuse and a congruent pair of legs, then you can prove the two triangles are congruent using hypotenuse leg. So if these triangles are both right triangles, so that's the first thing you need to know, and then their hypotenuses are congruent and their legs are congruent, a pair of corresponding legs, then these two triangles are congruent using hypotenuse leg theorem. Pause the notes and fill in your template if you need to. So, a key concept to hypotenuse leg is this. There are three conditions in order for you to use hypotenuse leg theorem. The triangles must meet these three conditions, or you cannot use HL. The first condition, there are two right triangles, so they have to be right triangles. The second condition is that their hypotenuses, the side that's across from the right angle, have to be congruent. And the third condition is that there has to be one pair of congruent legs. If your pair of triangles meet all three of these conditions, then you can use hypotenuse leg. So let's write a proof using the hypotenuse leg theorem so you can see what it looks like. Before we write our proof, let's plan for it. We are given that angle PRS and angle RPQ are right angles. So we're given this, that these are right angles. So that means what kind of triangles are they? They're right triangles. So that's condition 1 met on our list. These are right triangles. First condition was that they had to be. So that's met. 2, you're given that segment SP is congruent to segment QR. Well, SP and QR are what of these triangles? They're the hypotenuse. So condition 2 has been met. There's a pair of congruent hypotenuse. And then the last thing that we can tell from this picture is that they share this side. The side of a right triangle is referred to as a leg. So this leg, by reflexive property, is congruent to itself. So condition 3 has been met. Condition 1, they're right triangles. Condition 2, their hypotenuses are congruent. Condition 3, they have a congruent leg. So we can prove that these two triangles are congruent using hypotenuse leg. So let's write our proof. So the first thing that we said was we knew that these are right angles. That was given. Therefore, we can say that we know these two triangles are right triangles, because that's the definition of right triangles. It's a triangle that has a 90-degree angle. We learned that back in chapter 1. A right triangle is a triangle that has a 90-degree angle. The next thing that we said we knew were that SP and QR were congruent. That was given to us. And we said SP and QR, remember that's the hypotenuse. So step 1, we identified that these are right triangles. That's good. Step 2, we had to say they had a pair of congruent hypotenuse. So here we are. The next thing we said was that by reflexive property, this leg was congruent to itself. So we know that they are right triangles, we know that their hypotenuses are congruent, and we know that a leg is congruent. Therefore, we can prove that triangle PRS is congruent to triangle RPQ using HL, which stands for Hypotenuse Leg Theorem. Because we knew they were right triangles, that was step 1. Step 2, we knew that their hypotenuses were congruent. And step 3, we knew a leg. And therefore, using hypotenuse leg, we knew they were right. We knew their hypotenuses were congruent. We knew their legs were congruent. So hypotenuse leg proves that these two triangles are congruent. Let's take a look at another one using hypotenuse leg theorem. In this one, what's the first thing that we need to know? We need to identify that these are right triangles. Our given information here tells us that BE bisects AD at C. Does that tell you that these are right triangles? If I know that BE bisects, remember bisects means cuts into two equal congruent segments, right? BE cuts AD into two congruent segments is what bisects means. So that means that this is congruent to this. Does that show that they're right triangles? It doesn't. This, however, does. If I know that AB is perpendicular to BC, that means it forms a right angle. And if DE is perpendicular to EC, then they form a right angle. And if they are triangles that have right angles in them, then they are right triangles. Then the BE bisecting AD, well, that tells us that these hypotenuses are congruent. And then the last bit of given information, AB is congruent to DE, well, that's our leg. They have a pair of congruent legs. So you can prove this using hypotenuse leg. Is that the only way that you could prove this? No. From a mile away, you can spot them. You know that these are vertical angles. So you could have said angle, angle, side. True? That's another way to do this proof. These are congruent triangles. It means all of their angles and all of their sides are congruent. It's all about what you can prove. So you could have done it a different way. We've talked about how there's more than one way to do any proof. But we're using hypotenuse leg. So that's what we're going to use this example for. So step one, it was important for us to prove that these are right triangles first. Remember, that's step one in your conditions. So I took this bit of given information first to say that these are perpendicular. And because those sides are perpendicular, I know B and E are right. Oh, I meant to put a triangle in there. Right triangles. Because perpendicular lines form right angles and right triangles have right angles in them. So now I know that these are right triangles. Remember, that was condition 1 in our list. Condition 2, I know this leg here, AB is congruent to DE. I could have used this part and gone with the hypotenuse first. It doesn't matter as long as these ones that are the same color have to go together. So 1 has to come before 2. Then I'm using this, that BE bisects AD at C. And we said that that means that it cuts this into 2 congruent segments. It was important to say that before you said AC is congruent to DC by definition of bisect. Again, they're the same color. They have to go together. These have to go together. So these groups had to go together in order. 1 and 2 had to go together. 4 and 5 had to go together. Beyond that, you could mix these up any way you wanted. You could have put 3 first. You could have put 4 and 5 first. You could have put them in any order, as long as 1 comes before 2 and 4 comes before 5. These could be in any order. I'm proving that they are right triangles, that their hypotenuses are congruent, and that their legs are congruent. So 3 was independent of itself. It didn't matter where that came in. It just had to come in before this last step. The 2 triangles are congruent using hypotenuse leg. We've talked about it before, how if 2 different people leave my room to go to the cafeteria, then they might take 2 different routes, but they'd still get there. The essential part for you to understand is that in order to say step 2, you had to say step 1 first. In order to say step 5, you had to say step 4 first. Beyond that, it didn't matter what order steps 1 through 5 went in, as long as they all came before 6. You proved the 2 triangles are congruent because with 4 and 5, we said their hypotenuses were congruent. With 1 and 2, we said that they were right triangles. And with step 3, we said they had a leg that was congruent. So as long as you meet the 3 conditions, it doesn't matter what order you meet the 3 conditions in, then you know it. You know that these 2 triangles are congruent using hypotenuse leg. But it is essential. The first thing you know before you even think about using hypotenuse leg is that those are right triangles. You have to be able to prove that they're right triangles in order to use hypotenuse leg. If you have any questions, we'll talk about it tomorrow in class. We're going to practice all 5 ways to prove triangles are congruent.